Somewhere in the universe, a beam of light is traveling toward Earth. It is moving at the fastest speed reality allows. It is aimed in our direction. It is not tired. It is not slowing down. And it may still never reach us. That sounds impossible. Because light is supposed to be the thing that wins. Light from the sun reaches Earth in about 8 minutes. Light from nearby stars crosses years of darkness. Light from distant galaxies can travel for billions of years and still arrive in our telescopes. So, how can light be moving toward us forever and still lose? The answer is not that light gives up. The answer is that the universe can change the distance while the light is traveling. And in some places, space stretches so much that the destination keeps slipping away. To understand this, start with the rule everyone knows. Nothing can move through space faster than light. A rocket cannot do it. A planet cannot do it. A galaxy cannot do it by flying like a spaceship. This rule is not only about light. It is about cause and effect. It is the speed limit for information. If something happens over there, light speed is the fastest way the news can reach here. So, when people hear that distant galaxies can recede faster than light, it sounds like physics has contradicted itself. But there is a hidden difference. The galaxies are not necessarily racing through space faster than light. The space between us and those galaxies is expanding. Imagine two dots drawn on a rubber sheet. The dots are not crawling across the rubber. But if the sheet stretches, the distance between the dots grows anyway. Each dot can sit still on its own little patch while the space between them increases. The universe is not exactly a rubber sheet, but the idea helps. On huge cosmic scales, galaxies can be carried apart because space itself is expanding. Locally, light still obeys the speed limit. If a flashlight turns on beside you, the light moves at light speed. If a star shines inside a galaxy, that light moves at light speed. Relativity is still safe. The weird part is that space is not a fixed stage. Space is part of the performance, and it can stretch. This is where our normal picture of the Big Bang causes trouble. Most people imagine a tiny ball exploding into empty darkness. Matter flies outward. Galaxies become cosmic shrapnel. And somewhere behind all of it, there should be a center. But that picture is wrong. The Big Bang was not an explosion into space. It was the early universe expanding, not from one location into a room, but space itself growing everywhere. That means distant galaxies are not moving away because Earth is the center of an explosion. From our view, most distant galaxies recede from us, but from a galaxy far away, we would appear to recede from them. Every distant observer would see a similar pattern, not because everyone is secretly at the center, but because expanding space changes the distances between widely separated places. Now, put a photon into that expanding universe. A photon is a tiny packet of light. It leaves a galaxy billions of light years away. It begins traveling through space toward us. Locally, every step of its journey is normal. It moves at light speed through the space around it. But while it travels, the universe is expanding. The path ahead of it changes. The distance behind it changes. And the wavelength of the light is stretched with space. This stretching is called cosmological redshift. It is not the same as light becoming tired. Light does not slowly run out of strength like a battery. Instead, the wave itself is stretched longer. Blue light can become redder. Visible light can become infrared. Infrared can stretch into microwaves. That is why very distant galaxies look redder than they otherwise would. Their light has been stretched during the journey, and the longer the journey, the more stretching can happen. This is already strange, but it is not the most unsettling part. Some light is stretched and still reaches us. Some light is stretched so much that it becomes almost impossible to detect. And some light may never arrive at all. Imagine walking on a moving walkway at an airport. If the walkway moves slowly against you, you can still make progress. But if it moves away faster than you can walk forward, your feet are still moving and your destination still gets farther away. That is not because you stopped walking. It is because the ground beneath the situation is moving against you. For light in the universe, the analogy is not perfect. Space is not literally a conveyor belt, but it points at the feeling. Light can move locally at light speed while the total distance to Earth grows because space expands. In some regions, the expansion can win. This brings us to the cosmic horizon. A horizon is not always a wall. When you stand on Earth and look across the ocean, the horizon is the limit of what you can see from where you are. There is more ocean beyond it. But it is hidden from your position. The universe also has horizons. The observable universe is the region whose light has had time to reach us since the hot early universe. It is not the whole universe. It is only our visible patch. The edge of that patch is not a physical wall. There are no bricks at the edge of the observable universe. There is no sign saying space ends here. It is a limit created by time, light speed, and expansion. But there is another horizon that feels even lonelier. The cosmic event horizon. This is not just about what we can see today. It is about what can ever affect us in the future. If a galaxy is beyond this kind of horizon, then light it sends now may never reach us, even with unlimited waiting. Not tomorrow, not in a trillion years, not if we build a better telescope. The signal is not blocked by dust. It is not too dim because our instruments are bad. The structure of expanding space itself keeps it from ever arriving. This is the part that feels unfair. We can see some galaxies as they were long ago. Ancient light from them has already reached us. So in our telescopes, they are real images. They are part of our observable universe. But the galaxies we see are not frozen in that old state. Right now, those same galaxies are much farther away than they appear in the old light. And for some of them, light emitted today will never reach Earth. That means a galaxy can be visible in our sky and already be unreachable in a deeper sense. We can see its past, but we may never receive its present. That sentence should bother you. Because it means the universe is not only large, it is separated by time. Every telescope is a time machine, but only in one direction. When you look at the moon, you see it a little more than 1 second ago. When you look at the sun, you see it about 8 minutes ago. When you look at a nearby galaxy, you may be seeing light from millions of years ago. When you look across deep space, you are looking into a universe that no longer looks that way. The farther away the light began, the older the message becomes. And expansion stretches the message while it travels. So deep space astronomy is not like looking across a room. It is like reading old letters from places that may no longer be able to answer. This does not mean those galaxies have disappeared from their own point of view. They are not erased. They are not falling off an edge. They are not destroyed by darkness. They are simply becoming causally separated from us. Causally means able to exchange cause and effect. If you can send a signal to me and I can eventually receive it, we are connected in that way. If no signal can ever cross the growing distance, then we may belong to the same universe while being unable to communicate. Same universe. No possible message. That is the quiet horror of cosmic expansion. The universe does not need to build walls. It can isolate places by stretching the space between them. And the stretching is not slowing down in the simple way people once expected. Measurements of distant supernovae and other evidence show that the expansion of the universe is accelerating. We call the unknown cause dark energy. That name sounds dramatic, but it mostly means we do not fully know what is driving this acceleration. We can measure its effect. We can build models around it. But the deeper reason is still one of the largest unsolved problems in physics. If accelerated expansion continues, the far future becomes strange. Galaxies outside our local gravitational neighborhood will drift beyond communication. Their light will be stretched longer and longer. Their signals will become weaker. The universe will not suddenly go black, but the distant cosmos will become harder and harder to see. A future civilization in our galaxy might look up and see a much emptier universe. Nearby stars would still exist. Planets may still orbit. Science may still happen. But the evidence for the wider expanding universe could become faint. Future astronomers might live inside a universe that looks smaller than the one we can study today. Not because reality became smaller, but because the accessible evidence slipped away. That is one of the strangest things about knowledge. We usually imagine science moving forward forever. Better instruments, bigger telescopes, sharper images, more data, but the universe is not required to keep all evidence available. Some information can leave our future forever. There are things we can learn now because we exist at this moment in cosmic history. Earlier observers could not know them yet. Much later, observers may not be able to know them anymore. We are not at the center of the universe, but we may be living during a rare era when the universe is still talkative enough to reveal its scale. That should make the night sky feel different. Every faint galaxy in a deep image is not just a distant object. It is a message that succeeded. A photon left, space expanded, the wavelength stretched. Billions of years passed, and somehow the message still crossed the distance. It ended in a telescope. It ended as a pixel. It ended as a small mark on a screen made by creatures on a tiny planet. But for countless other possible messages, the story is different. They may begin their journey. They may travel perfectly. They may move at the fastest speed allowed and still never arrive. Not because they failed, because the universe changed while they were on the way. This also changes how we think about loneliness. When people ask whether other civilizations exist, they often imagine space as a huge empty distance we might cross one day. Maybe with better engines, maybe with patience, maybe with enough time. But cosmic horizons are not just engineering problems. They are limits written into causality. Even if a civilization exists beyond a future horizon, we may never exchange a single signal. They could have stars, planets, oceans, cities, their own questions about the sky. And from their view, we could be the unreachable ones. Not because either side is unimportant, but because the universe can contain many places that cannot ever meet. This is why the light that will never reach us is not just a sentence about photons. It is a sentence about the shape of possible knowledge. It says there may be real events that no future telescope can ever show us. Real histories that cannot become our history. Real skies that cannot send their present into ours. So, when you see a deep space image full of galaxies, remember what you are actually seeing. Not the universe as it is now, not a live broadcast, not a complete map. You are seeing surviving light, ancient messages, old versions of places that may already be beyond reply. From Earth, the universe appears to surround us. Light arrives from every direction. The sky feels open. But from most of the universe, Earth is not merely small. It may be causally unreachable. No telescope can fix that. No patience can wait it away. No faster rocket can carry a message beyond what light itself cannot reach. And yet, there is something beautiful about the messages that do arrive. Against expansion, against time, against the growing distance between worlds. Some light still reaches us. Some ancient photons still end their journey here. That they land in our instruments. They become pictures. They become evidence. They become the reason a small observer can understand something enormous. So yes, somewhere in the universe, light may be traveling toward Earth forever. It may never get tired, it may never slow down, and it may never arrive. The universe may contain more worlds than we can imagine, and still leave every civilization permanently alone.